Okay, welcome back. We're going to be looking at procedure 3. Under procedure 3 is determination of the density of a second liquid. Okay, in this experiment, we're going to be making use of two liquids. The first one is water, which is actually assigned a symbol of A. The second liquid in this case is ethanol. It doesn't necessarily mean it must be an ethanol, it could be something else, but so far, what they have been making use of is ethanol. So, for the purpose of this video, we're going to be making use of ethanol. Okay, so we want to know the density of that ethanol. Okay, I have here, this is an ethanol. If you actually look at it here, is actually, well, I bought this for the experiment I made use of. It got to this point, but subsequent practice, it has reduced. So we want to know the density of this, okay, because the person that actually sold this liquid to us, they didn't tell us the density. Now, why are we actually trying to get the density? Because subsequently in our calculations, we're going to be needing the density for further calculations. So for us to get the density of this liquid, recall that in step 2, we had earlier weighed this flask when it was empty, alright, and then it gave us 12 grams. So we had to also weigh these grams when it was filled with water. The sole purpose of doing that was to be very sure this guy is 10 ml. Okay, so the next thing we are going to do now, I'm not going to start pouring this inside because it's going to take time. For me to get the density of the ethanol, which is the other liquid, class, I will have to refill this guy again. But this time around, not with water. This time around with ethanol. Alright, I've actually done this before now in class. So remember, when I carried out this experiment in class, there was no cover. So the values we are going to be getting here will somehow be slightly different from the ones you'll be getting in the lab, because in the lab you'll be mandated to actually use a cover from what I learned so far from people that have done the experiment before now. So for you to actually measure the density of ethanol, remember we already know the volume of this, alright? All we just need to is the mass of ethanol, so we can use density equals to mass over volume. So you're going to pick up your, let me just do it. I'll pick up my pipette, plunge into my pipette sucker. Now I want to take solution here so I can transfer it into the pipette. I'm dragging it up now, so it doesn't really matter. I can take as much as I can because this pipette is 5 ml, alright, and this is 10 ml. So even if I fill this guy up, it might not really disturb. And I transfer it into this. If you look at the pipette, you realize that the water is going, the liquid is going down. So we take some more just to complete the volume of that guy. So this becomes okay. It has gotten to where I want it to be, the meniscus. So we are going to weigh this. Although I've done this before, I just want to do this so that those persons that missed out will at least enjoy. So I place this on top of this. We are getting 20 grams expectedly, because if water is of higher density than ethanol, so the mass of ethanol of course should be lesser because density is very proportional to mass. So we are getting here to be 20. Here is 20 grams. Okay, so the mass of flask is a mass of flask plus other liquid. The other liquid here is ethanol. The mass of flask plus other liquid, which is ethanol, is 20. So of course, from density equals to mass over volume, you can solve for the density of ethanol. The volume, if you open your manual, the formula is there to solve for density of the liquid. Page 8, you see formula for density of the liquid. It's going to be mass filled. Now look at this. Density is mass over volume. The volume of density is actually the volume of this flask. Remember, we had earlier calculated the volume of this flask. So this is 10. This flask, when it was empty, was 12. This flask, when it was filled with ethanol, was 20. That means the ethanol we added increased the mass of this to the 20. So for us to now get the mass of the ethanol itself, we're going to subtract the mass of this when it is empty from the total mass when it has the ethanol. So The mass of this flask with ethanol is 20 grams, while the mass of only the flask is 12 grams. So from density equals to mass over volume, we're going to get 20 minus 12 all over 10. Why are we using 10? Remember, 10 was the volume of the flask we had earlier calibrated. Okay, so I'm going to just write this out so that, so we have this, we say density, I use rho. Density, I say density of ethanol equals to mass filled with ethanol. Remember, we have two mass filled. The first one is with water, the second one is with ethanol. Mass filled with ethanol minus mass of the flask when it is empty divided by the volume of the flask. Now, the density of ethanol, we're going to get it using mass filled with ethanol minus mass of the flask when it is empty divided by the volume of the flask. Now, the mass of the flask when it is filled with ethanol is 20. The mass of the flask when it is empty, this particular mass filled is when it is filled with ethanol. This one is when it is empty. So this is over 12. 3 minus 12. The volume of the flask is 10. So this is 8 over 10, which is 0.8 gram per centimeter cube. So the density of ethanol is 0.8 grams per centimeter cube. Please, I would like to say this. Anytime you carry out calculations, all the answers you are going to get from the calculations, you're meant to record those answers in page 9. There are tables for the recording of the answers. We have two tables here. This first one, which is where we are going to be recording values we are going to get directly from the experiment, and then the values we get here, we are going to use it to carry out calculations. Right? That calculations, we have to record it in page 9. Okay, so in summary, what we have done in this procedure is to actually determine the density of ethanol. Now, density can be obtained using density equals to mass over volume. Okay, we need to know the mass of ethanol and we need to know the volume of ethanol so we can solve for the density of ethanol. And how do we do that? Now, we are going to pour in density into this flask where the mark is. The mark is actually 10 ml. But before we then, remember we had earlier measured the mass of this flask to be 12 grams. So when this flask is empty, it was 12 grams. Now when we now fill this guy with ethanol, we weighed it again, it gave us 20. To now get the mass of ethanol, we now say 20 minus 12, that is 8. Okay, now the volume, don't forget that the volume of this, we had earlier calibrated this volume to be 10. So we now say 20 minus 12, which is mass filled with ethanol minus mass of the flask when it is empty, divided by the volume of the flask, and that gave us 8 over 10, which is 0.8. Now, briefly, I did the calculations here. So if you look at this, I did the calculations here. Okay, so that is that for this second, this third step.